Hello, everyone. Welcome to today's webinar, What is BIM? Demystifying Building Information Modeling. We'll get started here in just a moment. Hopefully everybody's having a really good start to the week. Happy Wednesday. All right, we'll go ahead and give it another minute here, almost 12 o'clock Eastern Time. A few more people are filing in, it looks like. All right, so out of respect for everyone's time, let's go ahead and kick things off here. All right, so thank you everyone for taking the time to join us today for our webinar titled What is BIM? Demystifying Building Information Modeling. My name is Lake Lund, and I'm a business development manager here at Commonwealth. I'm joining you all from extremely hot Dallas, Texas today. It's supposed to be 92 degrees. I think we're actually going to break a record high possibly. So most of you are probably coming in from the Northeast or across the country, but really welcome everybody to today's session. So today's session is designed for professionals across the power generation and delivery engineering space, whether you're currently utilizing BIM or just beginning to explore this transformative technology. I've written an article titled How BIM is Revolutionizing Design Within the Power Industry. I'll be sharing the link to that article with you guys in the chat here shortly. Feel free to check that out once the session is completed. So a little bit about Commonwealth. We're headquartered in Jackson, Michigan, and we have 8 office locations spread across the United States. We are a soup to nuts engineering design firm with over 36 years of experience in the power industry. We provide expert engineering and consultative services that enable a more reliable, resilient power system. Our expertise spans renewable energy, system studies, or some people say calculations, consulting, power delivery, power generation, and of course, BIM. We typically use BIM for substation as well as power delivery projects. We have been using BIM since 2018, so a little bit over 6 years now. If you guys want to learn more about Commonwealth and some of the projects we've completed, feel free to check us out at our website, cai-engr.com. So today's webinar will qualify you for a PDH credit certificate. After today's session, we'll be getting those sent out. Expect those to be in your inbox before the end of the week. Moving on to the Q&A session. So we really want everybody to make this session as engaging as possible. So please, no matter what your question is, submit that question in the section with the icon Q&A up in the top right menu bar. And we're going to wait till after the presentation to get to those, but we'll get to all of your questions, even if we have to send you an email afterwards. So we'll make sure everybody's question gets answered. On top of that, like I said, we really want this to be as engaging as possible. So feel free to send a chat in the Teams channel. I'll be monitoring those. Our presenters will be monitoring those as well and try to respond to you guys as quickly as possible. So this webinar is being recorded. We have recently started a new YouTube channel, and all of our webinars are going to be placed on the YouTube channel. You can take a look at that at youtube.com/@Commonwealth Associates. Our next webinar will be in February of 2025. More details to come on this soon, so be on the lookout. And without further ado, I'll pass the baton along to Ryan to begin the presentation.
All right, Lake, thanks for that introduction. I'll be one of your presenters today. A little bit of background on myself. I've got about 18 years experience using various BIM tools and programs. I've done that across manufacturing, fabrication, construction, and now for the last 5 years that I've been with Commonwealth from a consulting engineering point of view. All right, so now I've got a little bit of information about myself out there. I'd like to know a little bit more about our audience today. What is your guys' level of experience with using BIM? Have you used it before? Have you used it a lot? Have you never used it before? Do you even know what BIM means? We're going to get a poll set up and get that out to you and get a little bit of feel for what your level of expertise is on this topic before we get started here. Just a little background on what we're going to doing for the presentation today as well. We're going to have kind of a four-part presentation here. The first part of the presentation is going to be kind of a high-level look at BIM from a substation standpoint. And we're going to go through some frequently asked questions that we see on this. We're going to go through those, and once we get through the frequently asked questions and kind of the high-level look at it, we're going to hand you off to some of our subject matter experts, and we're going to take a look at how protections and controls, physical, electrical, and civil structural do their designs using BIM tools. It looks like we're getting some answers here on the poll. All right, so yeah, it looks like we got a little bit of a mixed audience here. That's good to know. So yeah, without further ado, I'll get started with the presentation. What is BIM? Demystifying building information modeling. We'll look at this from the substation standpoint. All right, building information modeling is what BIM is. It's an acronym for that. What it is exactly is it's a process of using 3D modeling intelligently with metadata in it to more efficiently plan, design, and construct jobs. We usually do this from an engineering, procurement, and construction standpoint in our industry, and it's very much a collaborative effort. It's a collaborative effort between different companies from different departments inside a company, and you can kind of bring all that information together using the modeling process and the smart features of it to kind of collaborate together and run a project a lot more efficiently doing that. Some of the benefits we've found from using this over the years is just the visibility you get from doing 3D modeling is you're able to get the 3D models in place and you can rotate, see everything. People can work on those models together at the same time. You can collaborate easily between what you're doing on various different levels of the project. Another very important thing we've seen, and anybody who's worked in construction know how important this is, but you can use some of the tools to run clash detection, and you can see if you're going to have a detection of a clash that could be underground, above ground. You can bring in models from your structural, your siting, your physical design, bring them all together, and once you do that, you can determine how everything's going together and if there will be any potential issues on the site a lot farther ahead of time, because anybody who's worked in construction and been to a site that's had an issue with that knows that that's a lot of heartache and pain late in the game that if you can catch that earlier would be very beneficial to everybody. A couple other things, these kind of go hand in hand, but communication and collaboration. Since we're using the same information and working off it from the same time in a BIM process, the communication collaboration really allow you to get really good insights into what's going on in the project. And you can do that from a very early stage in this as well. So that usually results in a lot more efficient and higher quality designs over time. All right, so we're going to look at some programs here. And these programs we're going to take a look at, from an Autodesk point of view. There is other clients out there that do provide BIM softwares. Bentley, Dassault Systems, to name a few. There's a couple others as well, but from what we do in-house here, Autodesk is kind of king of what we do and what we see in our industry. So what is Inventor? This is the tool that we generally use for doing physical, electrical, and structural design. It is a 3D parametric that allows you to draw individual parts and pieces and then create those parts and pieces into assemblies and sub-assemblies. And that gives you a larger model as you keep building upon itself. The next one is what is Civil 3D? Civil 3D is kind of your siting and civil design tool. This allows you to set up your grading, your design studies, and optimize your site layout and design using point clouds and develop kind of a 3D model of what the the actual grade and site will look like. All right, this is AutoCAD Electrical. AutoCAD Electrical is the tool that protection and controls primarily use in a substation design. It's going to look very much like AutoCAD when you look at it, but the important parts of it is it uses smart components that allows you to put metadata into the components themselves that allow you to build the schematics in a fashion that once the schematics are built, you can kind of project those schematics into wiring diagrams much easier and more accurately, which is there's a lot of time savings in that when it comes to creating those wiring diagrams later, and the accuracy, because it's already been set up once, you can just kind of push it through to the next level. Right. What is NoviceWorks? NoviceWorks is your project management tool. So this is where you bring all of your BIM files in and you coordinate them together. So you can bring your civil 3D model into this, and you can take your foundations and structures and bring it into to NoviceWorks, and then also your physical electrical equipment, bring them all together, overlap them, and see how the site's actually going to look. You can also bring multiple departments, like I just mentioned in, but you can also bring multiple different companies. If you have a particular site that's got different inputs from other people, you can use this tool to bring those models together and see what's going on. And this is also the tool, something I mentioned earlier is clash detection is a very important thing when using some of this. And this is the tool that you'll run those clash detections in. You can actually run a report and it'll just spit out a list of clash detections that it picks up on. So a very powerful tool from a project management standpoint for coordinating and collaborating these projects together. What is Autodesk Vault? Vault is going to be your product data management system. This is where you bring all of your files together and you store them in a centralized location. This allows all of your linking to be maintained when working on the project. Working off a centralized location allows you everybody to come work in that area on the same files at multiple different times. So if structural updates, say a switch stand, and we have a switch mounted on it, physical electrical, when they update that model in Vault, that then pushes directly to our model that we have the switch set up on anywhere that could possibly use. So that information pushing across allows for that information to be picked up a lot quicker and don't have to go through a bunch of back checks to figure out if your models are current, because if you're working off the information in the same location, like a vault, that information should always be current. All right, SDS. SDS is a Autodesk add-on project, and this is what we use to help us do substation in our Autodesk project. This is a third-party service, but allows us to do 2D and 3D module design using the subset of tools that they have available to us. Allows you to do above grade design, below grade design. It has some built-in capabilities where it can check for your parts to phase, your phase to ground. It can do your insulation coordination studies. It can do your insulation checks. It can do a lot of specialized things that really are necessary when developing and designing substations specifically. This next slide is kind of a look at some of the toolbars, and what some of the abilities we have in the program. When we get into the subject matter expert presentations later and demonstrations, we will go over some of these tools and how they work. Not all of them, because there's a lot of them here and we have a short presentation, but we will cover some of these, some of the more beneficial ones that we see doing substation design. All right, what is level of detail? Level of detail is an important part of substation design and just running a BIM project in general. There's levels that go from level 100 to level 400. Level 100 is basically a tag and a symbol in place, and level 400 is a full model that shows all the internal workings, every part's there. It is as accurate as you can possibly get it. Generally, what we see in our designs is the level of detail needed to do a substation design. We don't have to go to the extreme. We don't have to go to that 400. So most of ours fall somewhere in the 300 to 350 range, which you can see the overall dimensions and size, and you can see some mounting patterns. And that's really what we use for substation design. And this is important as well because when you start building these models, the more detail you put into them, the larger the files that you'll be working on will be. So having a streamlined but accurate model is important for doing large assemblies like this, which when you get a substation all together, it is going to end up being a very large file. And if you without a strong computer with good graphics cards, the level of detail can be very important on how that's going to run. And also, the level of detail plays directly into how much time it takes to draw and develop the parts, which is a direct cost involved in creating vaults and libraries. How does Inventor help with bill of materials? This is one of the biggest benefits we see from doing a BIM style project is using Inventor and some of these tools. It can auto-generate your master bills of materials based on the smart information and metadata you're putting into your iProperties for your Inventor models and your other models. I'm sure many of us working on 2D projects in the past have had those days where we're sitting there hand counting hundreds of parts, hundreds of connectors, grounds, conduits, and we're hand counting all of that. If you've done your 3D model and you've got all of your metadata in place correctly, that'll auto-generate that and save you tons of time on doing those things. It also saves you time on QC checks later. You don't have to do as deep of a dive into that, assuming the models are correct and you're checking the models, then that QC on that part of the bill of materials is a lot easier later in the project. All right, let's look at some pros here. What are some pros of using the Autodesk products? We find them very user-friendly. Autodesk has been around a long time and been doing this for forever. They know how to streamline everything and get it so it's easy to understand and use. As mentioned a couple times before, detection and clashes is very important and can save a lot of field issues, a lot of rework. And with early detection, you can increase your design speed as well, and you can get those figured out well before we have an issue in the field. A smart bill of materials, of being able to auto-gen bill of materials, the accuracy you get with that, the time savings you get with that is really, really important. And we also see with Inventor specifically as model translation is very, very robust, as you can translate almost any 3D model that we've come across into something that's workable. Anything from Revit files to SolidWorks files to generic step files, they all translate pretty well into Inventor. So any client or manufacturer or vendor that sends you a 3D model, using Inventor, you can usually load that up and use it in some way. Drawing links to models, it's very easy to take a model, bring it over to your drawings, put those models in there and show exactly what's going on in multiple different levels. As we get into our structural design later, we'll take a look more in depth into that and the actual demonstrations part. There's a lot of cool things you can do with linking those models together. Also, parts libraries, getting a part library or content center. Sometimes these come standard with AutoCAD or SDS. Using those and establishing a good part library is really going to make not just the first job you do, but every job you do from then on a lot simpler, a lot easier with a standard parts library. All right, look at some cons, because nothing's ever extremely perfect. So one of the cons is you're going to require a fairly strong computer. I think a minimum for using this is you're going to want at least a 16 to 32 gigabyte RAM system, and you're going to want a fairly robust graphics card for doing 3D modeling. It doesn't have to be a top of the line one, but it also you can't have a really low end one, because if you use low end equipment or you have low RAM, you're going to see some lag issues when you get into some of these bigger substation designs. Another thing, engineering up front, there's a lot of planning, there's a lot of creating libraries. Traditionally, our industry uses like a 30, 60, 90. And a lot of times that 30% is like a plan view. Well, if you're doing a plan view in 3D, you kind of have to draw the full model. So that means the shift of focus of drawing your model, where now like a 2D plan view, you can probably do something pretty basic and make it look correct and spend just a few hours doing that to get the idea out there. But if you're going to do a 3D model ahead of time, you really have to build that up. So your 30% are going to be more robust than they are using a more traditional model of a 30, 60, 90 with a 2D CAD. Also mentioned earlier, there's some potential cost to implementing BIM. Creating your vaults, creating your parts library, those things all play into how much it's going to cost to get you set up and running using BIM. Also, document storage and data management. If you do not use a vault like a PDM system we showed earlier, and you use something local drive or you used a server or something that does not use that information, it's very easy to move things, change things, and break links. And sometimes it'll take hours to resolve those link issues. So it's kind of critical that if you do an a BIM system, that you have some sort of PDM built into it to save you a bunch of time. But again, that is also a costly endeavor if you're not set up for it. All right, so that ends my portion of the demonstration. I will hand you off to your P&C subject matter expert, Tim Alley, to do his presentation.
Hey, thanks, Ryan. Sharing my screen now. My name's Tim Alley. I've just celebrated my 25th year of working here at Commonwealth Engineer. I've been working in AutoCAD Electric for roughly about 2.5, 3 years. To start with, can you guys see my screen?
Not yet, Tim. I'd try that one more time. There we go. Perfect.
Okay, good. So to start with, I just wanted to give a quick explanation of how AutoCAD works. You know, back in the old days with AutoCAD, you drew things with lines and circles and text, but none of those were really associated with anything. So to actually sit down and write a program that could go in and read a CAD file, you'd be lost because you couldn't see what's connected to what. It would be very difficult to do. So to solve this, AutoCAD made this AutoCAD Electric, and the way they handled that problem was to make blocks. Blocks are just a collection of lines and circles and shapes that are bound together as a block. A block's been in AutoCAD since the beginning. And the key thing they did to a block is they added attributes to them. And I'll be showing you a few here in just a second. But an attribute is just simply a piece of text that has a name to it and it has a value. And that is where all of the data, the metadata, is stored in your drawings. And then with those blocks, which have the attributes, they call those components, and they're linked together with what we call wires. The wires can be grouped together into cables with wire colors, etc. And I'll go into our next slide. Here is just kind of a breakdown of what I was describing. You got a graphic version of the block. You assign these attributes with tags and values to it. And then together, that is your smart component. So an example of a smart component throughout your drawings, you would have a schematic version. Here's an LED showing up on the schematic. Your wire diagram version is next to it, and then the front view. Now, what links these together in AutoCAD Electric are 3 attributes: the installation, the location, and the tag. All 3 of those values have to be exactly the same, and that's what links those together throughout the drawings. The next component I just wanted to show you was the terminal block. These are pretty key to the design. You got your schematic version, and on the schematic, you have to mark each side of the terminal block as far as what is the internal side and what is the external. So that's how AutoCAD knows where to land the wires when it goes to do the wiring, is by you identifying that. And similarly, in your wire diagram, you have to label the terminal block, what side's interior and what side is exteriors. Now, one of the key relationships in AutoCAD Electric is this parent-child relationship. This is a one-to-many relationship, meaning you have one parent and it can have many childs or children. And a child can only have one parent. And it's a top-down arrangement where you can have data in the parent that can then share that information with the child. But going backwards, it doesn't work where the child doesn't then give information to the parent. It's top down. So I just gave you a couple of examples of, this is a lockout relay where the coil I made as the parent, and then each of the different contacts would be the child. And you can see that the attributes are the same. Notice the tag one, the parent has a tag one attribute, and that one identifies it as being a parent, where all the childs are twos, tag twos, but the value is the same. So that links them together, that they're related, but the one and the two denotes which one's the parent and which one's the child. So the system that we're going to talk about today, this is the one line. We've got a high side switch with a motor, a circuit switcher, and a distribution with two high side CTs, two low side CTs, and a neutral CT. And for the PNC side, I was going to show you how to connect the CTs to your relays and the relationships between those. So in the PNC world, the one line is the roadmap. It's what we always start from. It's where the drawings begin. And here I took the CT and I identified it as being part of transformer one. And then the first CT, I just labeled it CT1. And then the data that I want to show on the one line is in the description fields. And I did the same for the CTs, just naming them sequentially. Now, notice that these are child components. And there's a little trick we do because, like I said, the data doesn't normally pass from a child to a parent. But I'm going to show you one way that you can do that. So this is your child component. And then the next thing you could do is you would insert your CT symbol that would go on your schematic. And AutoCAD Electric is very schematic driven, meaning you want to develop your schematics first, and then after you develop your schematics, AutoCAD will then read them and then populate your wire diagrams off of the data that's in there. And so this would be the schematic that I would start with the CT circuit. And when I go to name it, this is part of the SDS toolkit here. One of the added features that really make it nice is I can come in here and I can assign that tag, but instead of typing everything, I can hit the schematic button and it'll pull the drawings and pull up a list of all the other tags that I've already got put into the drawing. So what I'm working with now is CT1, so I would select it. And then when I do, it pulls in the data that I had from this child because I selected its tag. It will pull that data into the parent. So now I've populated the parent CT circuit with the CT ratios and the name. Then I would go through and I would edit more data in there, given the more information on the CT that I'm connected to. And I would also include the phases. So this is that first CT, and I would identify what phase it's connected to. Then after doing that, you would then have to add these terminal blocks. So these are the actual terminal blocks in the cabinet that your wires are going to land on. And when you finish up, you would have a CT circuit like this. Now, working with your three-line diagram, you could put your three-line diagram together. And so this CT over here on top is the same CT over here on top. And to relate them so that they're together, you just name this CT the same as what this is. Now this one will still be the parent, and then this one will be the child. And when you do that, when you name that, it'll pull the data from the parent onto the child. And notice how the phases came over with it. So you can get a visual of what's connected to what phase. And you do that for all your CTs. And notice on the second one, I don't display the phases, and that's intentionally. That data is still there. It's just an attribute that I chose to turn off because I didn't want to see it. It clutters up the drawing. So these attributes can be turned on and turned off as needed. So this is kind of the complete system of that CT connection. We see that this CT is the parent, and these are other parent CTs. And it just showing the relationship of what the parent is and that these are both childs to it. And the data from the parent is transferred onto the child. So, and I can show you when I get into the demo part of it, I can change the CT ratio over here on the parent, and then AutoCAD will go through and update the CT ratio here over here on the one line. It doesn't show on the three lines. So that was the end of my presentation. Now to the demo part of it. For simplicity reasons, I've combined these three drawings into one so that you can see them. Normally, I would expect that your one line would be a separate drawing, your three line would be a second drawing, and then your CTs are shown on a third. Now, some companies I know like to show their CT circuits on the three line, and that's certainly possible. But in this case, we just chose to show these CT circuits separately on a different drawing. So AutoCAD Electric is very robust. You're able to do anything you really want to do within certain limits, but it's very robust. So one of the tools I was just going to show you, they have this rollover tool, and by selecting it and then going over top of the CT circuit, it draws what they call chicken tracks, showing you what's related to it. So this is one reason I decided to combine this onto one drawing. If I was on multiple drawings, you wouldn't see these chicken tracks. So you can see what's tied together. So it's very handy to be able to see that. And then I'll just show you a little quick, like if I wanted to edit that, and I'll change the ratio to 400 to 1. Hit OK. It updates it here. And then it's found other ones and asking me, do I want to update it? Yes. And then if I go over here, you'll see that it's updated there as well. Another thing I was going to show you is these terminal blocks. Here you can see where I've marked which side is external and which is internal. Hopefully that now makes more sense. You know, this cable is ran out in the yard and it's connected on the external side of the terminal block on the breaker, and then it's also connected on the external when it hits the panel. And then on the panel, you have wiring that goes internal to the panel. Just to show you what else I got set up here. Here's that connection diagram for the transformer. I've already annotated the CTs and fanned them out so you can see that the cables and this information is pulled from the schematic. I saved that for the wire diagram. So here's our wire diagram I start with, and you can see there's no wires on anything. And this is where I think you get your biggest bang for your buck in AutoCAD is I want to now complete this wire diagram. So the first step is you got to do what's called annotation, and there's lots of different variables you can set to format the text and how it appears. And I'll just leave that to the default, but I can just select what I want to annotate. And it could have been, I'm doing the whole drawing. It could have just been one terminal block. But right now it's reading the drawings in the schematic, and it's populating based off of the schematic. So a little bit on the slow side. I mean, you're sitting here waiting, but if you think about how long it would take you to do manually, it's quite fast. We're almost done, I believe. Doing the last relay, then it does the terminal blocks. So on the wire terminal blocks here, you can see the wires that were landed on the exterior, and you can see on the annotation the cable number. But to get it to look like an actual cable, you can fan each one out individually, which I'll do real quick. I'll just do this one real quick. You got to pick what kind of cable you want. I want it with a shield. And I want the cable label to be on the right side, so I'll pick that. And then I just pick the individual wires that's part of that cable. I got them selected. Now I click, and then it allows me to adjust it. And if I go down, I can have them pointing down, or I can go up and point it up, or I can stay in the middle and go straight out. Then I hit a point where I want to adjust this, and it stops. And then I can put my cable header on it and adjust it. So that's doing it manually by hand. But there's also a faster way to do it. You can do auto, and again, I'll just set it with a shield, and then I'll do it drawing wide. And now it's going to fan out all of the cables that's on the wire diagram, and there you go. So it did them all at once for you. And there's settings in there that you can adjust to find how you want these, pointed up, pointed down, whatever. So that's all I had for the demo. I apologize for going so fast, but with the short time period, I wanted to cover as much as possible. With that, I'll wrap it up and I'll hand it over to Greg.
Thanks, Tim.
Thank you.
Right. My name is Greg Herrick. I'm a substation design technician for Commonwealth. And I'm going to go through the Inventor SDS interface that Ryan described earlier in his presentation. So we have a small assembly here of a couple of just random pieces of equipment we had been placed into this assembly. We're going to go through some of the SDS tools that are available. All the way over to the left, we have connector and bus fitting tools. You can set up libraries of some of your most commonly used connectors and fittings and be able to insert those into your assembly pretty quick, along with rigid bus routing tools. So you can quickly run rigid bus through your assemblies We also have cable routing tools, which I'll show in a minute. You can pick work points and connectors and quickly and run some cables and conductor through your assemblies. There's also lightning protection shielding tools where you can add shield wires, connect them to your structures, and do some analysis with rolling sphere. Come to the below grade tools. You have some tools to be able to create grounding grids and add taps to your grounding grids. We also have trench tools. We're not going to be showing any of these today. We do have also conduit tools where you can create some conduit drops from your equipment and show it going through your foundations or across your station if you like. We generally don't show a lot of below grade conduit because it is very computation heavy on your computer system. So we'll get into this small assembly here, and you can notice that there is some differences in the level of detail of equipment like Ryan had described. We do have some of these surge resters that have removed the sheds off the insulators. Also on the circuit switcher, the switch, the center break switch here it's got a very basic level of detail. And normally this is about the level of detail that we would go for just to reduce that load. Once you get into your larger stations, it can get a little bit laggy if you're rotating your station around, doing different operations. So we also show starting off on your initial design, you're going to want to create a layout where all of your equipment is going to go, your drive paths, where your control modules are going to go. We have that separated out here as well so that when you do create that, you can go in and quickly pace and constrain your equipment in and know where everything goes. And you can go in and separate out where your drive path is. And you can take out that visibility if you wanted to, or take away the layout as well for your equipment. So it's really nice to be able to turn certain things on and off while you're working. And this off to the left is the model tree. So this is going to be where all of your components are going to show up, everything that you want to place into the assembly. And this is a great way to keep everything organized. And the best part about this is if you want to know what something is, you can right click on it and tell it to find it in the browser. If you say, I don't know where I put this, that's right here. Then you can drop that down. You can see all the information that's related to that piece of equipment. So we have some of the constraints that are on the equipment of how it's placed into the assembly, as well as one of the things that Ryan had touched on was iProperties. So iProperties, right click on the equipment, come all the way down to iProperties, select that. You can get in here and it's got just all kinds of information. So you can get in and see your names of your parts, who the designer was, what its current status is. And the best parts is adding in custom iProperties. You can come in and add part numbers, BOM numbers, manufacturer's part numbers, and have that all readily available to you at a single click. So can come in here and you can see I have all the connectors organized by the equipment connection. You can also see conductor, and you could go in and see how long each piece of conductor is, what type it is, give it a different name. We also have foundations and steel. So we can identify each foundation, what its name is. We can go into iProperties, set custom iProperties on all of that. And to demo some of the tools real quick, you may notice we're missing a piece of conductor, and we have a connector that's out of place. So we're going to add a constraint to that connector that's here. It's floating out in the middle of nowhere. It's not constrained to any piece of equipment. We'll come up here to the joint command, create a rigid joint command, and we'll select our face that we want to constrain on the connector. And it's going to light up this hole here. We're going to tell it we want to line it up to this face and this hole. And it's going to give you a nice little animation. Hit OK. Now that connector is constrained to that piece of equipment. It does not move. We need to add in our conductor. So we're going to go to our above grade tools. We're going to go to our above grade settings. We already have our conductor that we want to run selected. And you are able to set your sag as well. So you may notice there are some additional points here, and these are work points that are defined by some of the SDS user guides on running conductor, and it's to help guide the conductor tool on how to run the conductor through your assembly. So we're going to go here. You have a lot of different options on how to run that. Picking cylinder surfaces, fittings, points. We're going to go to pick points, and you're going to select in order the points that you want to run for the conductor. So you look inside of this connector, we do have a point at the very end. Select that. This other guide point on the mating conductor, and then the point at the end. And then we're going to hit enter. And it's going to generate a nice conductor for us. You may notice that from the side that the sag is a little bit different, doesn't match the other conductors, and we can fix that. We can go in here and hit our edit cable tool, hit that, and we'll change that to 8%. And then it's going to go ahead and update that. And you can see that all of those match now. So we can also come in and set our phase colors. So we'll click on that. Come up here, set to phase C. Now we've got to match all the rest of the conductor. You may notice when we created that new piece of conductor that it's just put down here in the bottom of our model tree. So we wanted to organize that, and we're going to go ahead and just click on that and drag it right to the conductor folder. And it's going to put that in there. And now we're all back and organized. Let's see. So one of the other things I can show is there are design check tools. And one of the things that you can do as well is with your trench and conduit, you can also check your conduit fill and trench fill within some of these design check tools, which is nice rather than having to manually do that. So that's all I have. Matt is going to go ahead and show you some of the other drawing tools. Matt?
Thanks, Greg. Let me share my screen here. My name is Matt Nguyen. I'm a civil structural engineer over at Commonwealth. I've got about 8 years of experience in different industries, but just fairly new to substations in general. I've been here about 2 years, but the philosophies of BIM, whether it's between disciplines or between industries, I think are very similar. So a lot of the stuff, keep in mind, it does translate, even if you're, say, looking at a P&C drawing. The parent-child relationship is very important, even in structural. Blake, can you verify that you can see my screen?
Yeah, Matt, you are good to go.
Perfect. So here you can see that I'm starting off with the same exact model that Greg was just showing. This will be a shared model where we are all making our drawings based off of this model. Really, Greg has shown you the intense power that you can put into any sort of model. This could be as simple as something like this, where it's only showing a couple connection points, or something as complicated as, say, this transformer. But the idea is that we're all using a shared model where all the information lives. But what do you do with this shared model? Maybe a client, is unwilling to accept just the shared model. How do you generate drawings from this model? And so I'll dive into just the structure side of things. You can see here, this is the same exact structure from this file. They're actually linked. You can open it from here and access it and everything. And really using, say, this piece of the entire site is just a single structure. And I want to develop a structural steel fabrication drawing from this. Within Inventor, you can initially, yes, generate views somewhat simply, just based on your model. You can place a view, you can tell it the scale, change it to whatever views you would like. All that's automated. You can show hidden lines or not. It's a much easier than say, hey, look, I have an idea for this structure and I need someone to draw it up and draw each line if it's hidden, show me a side view, a front view. Everything's automatically generated, and it also is very dynamically linked. So as soon as you, say, make a change in your model, let's say you have a very complicated structure. You go through and change a million things on the structure itself. Great, you really have to go through and change every drawing? Well, the answer is no. It automatically updates to whatever changes you have made. And that also goes back to the idea that whatever changes another discipline, say, or another company may have made, you should be able to see that if you are all referencing the same base file. Now, on top of view generation and views being, yes, dynamically linked, you can also pull metadata from each individual view. For instance, this is just the column of that structure, and I want to call it like every single piece of steel here is tagged with what we call a mark number. And in order to call this out, you would, back in the older days, you would have to come in here and literally type in C1A, and you'd have to go back and reference, okay, that is actually C1A. Well, now you can quickly just paste in something C1A. I know this was one C1D. If I attach it here, it will automatically update to say, okay, cool. This piece of information is tagged to this actual plate. This actual plate's mark is C1D. This is this is a internal standard that we've set. You can choose to do whatever piece of information you wanted to pull from here. If you wanted to know, say, what the cost of this plate is, who you've assigned to manufacture this plate, you can also pull any sort of metadata out of this this view here and really call it out very easily and very quickly in a multi-leader. Now, moving on to what Ryan has discussed with the BOMs, this is what, as far as structural steel goes, this is what we found to be the most beneficial to us. The BOMs, just like a view, are dynamically linked, meaning, I change this plate thickness to 2 inches maybe, and this will automatically update. At the same time, yes, this is automatically generated, so I could easily just, plop this in and it will automatically be filled out. Nothing, you don't actually have to go and say, type in A36 for a material. All this is automated as long as this information exists in your model. That's very important. And to that idea, you don't really want to be going through just like in the old days where you had to type in, all right, well, I have to fill in my materials now. You don't want to go through your entire model and just type in a bunch of materials. That seems like the same amount of work. What you do want to do is get into a content center like Ryan described, where whenever you're generating, say, an HSS or a plate or really anything from steel to electrical equipment, anything at all. Once you generate it using a content center database, it will automatically populate. Ours internally, for instance, anytime you place a plate, it will come in as A36. Anytime you place an HSS, the default material is a certain material. Keep in mind that can be extrapolated to anything from physical materials or a piece of equipment. Say you have a preferred vendor. Every time you place in an insulator, it may default to a preferred vendor. Now, another cool feature with the bill of materials is not only it's not a one-way ticket. Yes, once you place it in, all this data actually exists within all these actual files, but you can also push data into those files. This goes back into the parent-child relationship that was described earlier, but in this scenario, you can push data very easily into children and the other way around as well. You can see here that I can say add a custom column, and for just quick testing purposes, I'll add one here. Let's say test 1. And now, yes, it may look like that just happened on this quick table, but if I actually open that individual part and go deep dive into its eye properties, you can see that that actually exists here. So say you have this structure that occurs 10 times over your entire site, and you want to add a piece of information to it. Hey, look, we found out that it'll cost this much from this vendor. Okay, well, I can quickly go into my drawing, push all that data into those individual parts, and that will reflect in every instance that occurs. Maybe you have 10 different drawings for each one of those structures. It will reflect appropriately there. On top of that, I really wanted to do a deeper dive into the content center and how you really need to think about your bill of materials as well as your any views that you are showing. That's really how you want to develop your content center. Unfortunately, we're running out of time a bit, but that is exactly what you really need to think about when you're generating a content center and really having that upfront cost of how are you building your library and how do you want your library to be read? What do you care about? Maybe you don't care about material. Maybe you work in procurement and you would like to know a date on every single piece of anything on this entire site. That also can be pushed into the metadata. So going back to Greg's presentation, yes, you can put whatever metadata you want in, but think about not trying to make it overkill. Do not make your model too strong where it's unworkable and you can't even move around in it, but you want it to a level of detail where you are extrapolating drawings. Like, what do you actually care about when what your final product looks like? That being said, I'll hand it back over to Lake for Q&A, but please let us know if you definitely have any questions or comments or concerns with anything we're showing here.
Sounds good. And Matt, it doesn't look like we have any questions at the time, so if you needed to finish anything up, feel free to do so. Go ahead and take over the screen if not.
Should be good, Lake. Thank you, though.
Okay, perfect. All right, so let me check the Q&A in the chat function one more time here to see if we have anything coming through. It doesn't look like we do at this time, so we'll just go ahead and close everything out. So thank you, guys. Thank you to everybody so much for joining us today. We greatly appreciate it. Thank you to our presenters and everybody who joined this presentation. Again, we will be sending out the PDH credit to the email that you all registered with by the end of the week. Our next webinar will be letting you all know what the topic is going to be here shortly, but that's going to be in February of 2025. So be on the lookout for that. We look forward to seeing you there. If you want to review the webinar that you currently just watched and send it out to any other colleagues, take a look at our YouTube channel, youtube.com/@Commonwealth Associates. And again, I'm Lake Lund, a business development manager here. So if you guys do come up with any outstanding questions or you guys want to learn how BIM could possibly benefit you or your company, feel free to reach out to me. My email is listed here, but it is lake.lund@cai-engr. Appreciate everybody, and you'll have a good rest of your week.
Yeah, like I do see a question in the chat. Was this all just based on AutoCAD Inventor? So the structural part of it and the physical part of it, we did use this AutoCAD Inventor for that part of it. The P&C portion that we looked at earlier was based in AutoCAD Electrical. We didn't show like Civil 3D or Navisworks is based on time constraints in itself, but the Autodesk library itself kind of works together and allows information to push across between things as well. Like there's things you can set up in AutoCAD Electrical with wiring and cables, and you can push that right across into Inventor, and that's how you can kind of automate some of your like Greg mentioned earlier, some of your conduit fills and things like that. So yeah, it's a multitude of programs coming from AutoCAD, Autodesk, I guess, itself.
Great. Thank you, Ryan. Sorry I didn't see that come through. Anybody else have any other questions? All right, it doesn't appear so. Well, again, thank you everybody for joining. We look forward to seeing you all at our next webinar, and reach out if you guys have any questions or want to learn more. Appreciate everybody's time.